So hello everyone and welcome back to another video. This right here is a GTX 980 Ti G1 Gaming from Gigabyte, and this is one of 5 cards that I got sent by a person who just kind of accumulated 5 GPUs over time, which were all in unknown or non-working state, and they didn't know what to do with them, so they offered to send me the cards for basically only shipping cost, which is why I have them now. And yeah, so this 980 Ti was supposed to be the easy one to get working again, but, well, for some reason G1 Gaming 980 Ti's are just bad luck. Or just 980 Ti's in general are bad luck. I have like 5 980 Ti's and only one of them works, and that one that works also almost didn't end up working because some idiot put liquid metal on it and it like almost seeped under the core. Anyway, so this thing's not working and it cannot be made to work. This thing is not coming back. I've already done all the troubleshooting and repair attempts. And this video is basically just to tell you about what happened, because this is another one. Like, this is the exact same story as the last G1 Gaming 980 Ti I had. This card would have been repairable, but someone who had the card before me, it's not the guy who sent me the card, like, the person that sent me all these cards, like, got them from various sources over time. So, like, it's not them that did this to this card, it's someone else. And that someone else tried to repair the card, but obviously didn't know what the hell they were doing, and in the process broke the card so much that it cannot be repaired anymore. And yeah, so this is gonna be the story of what exactly happened. So, I'm gonna take the cooler off to show you the PCB a bit, and I guess meanwhile I can start telling you the story. So, before I even got this card, I already knew exactly what is wrong with it, because this is a G1 Gaming 980 Ti, and the G1 Gaming 980 Ti is famous for doing one specific thing. Actually, there's 2 things that this card can do, but there's one failure that is significantly more common than the other one, and that is that the memory VRM has a meltdown. So yeah, and like that. That is exactly what I got, because the memory VRM on this specific card is underpowered. I can show you in what way, as soon as I have this off. There we go. I also didn't get any thermal pads with this. So like the card had already been stripped, obviously. So, yeah, here's the PCB. And the problem with the G1 Gaming's memory VRM is, so you see how there's 4 dual end FETs right here. By default you don't get that. By default you only have 2 dual end FETs populated, and then the other 2 right here are just empty. That's just empty dual end FET pads here. Now, I've already done all the repair that I can do to this card, and part of that is just adding 2 more dual end FETs so that this VRM doesn't blow up again. So yeah, but yeah, so like before I got the card, I was already just like, oh, it's a G1 and it's dead, like 100% the memory VRM is blown up, and that's usually a very, very easy thing to fix, because the memory VRM on this card is powered off the PCI Express slot, and when you look at this solder blob right here, that's where a fuse used to be. So Gigabyte puts, like, yeah, more often than not, they put fuses on their PCI Express slots. They sadly don't put them like on the 8 pins, but they rather consistently have a fuse on their PCI Express slot. And because the memory VRM is powered off of the PCI Express slot, when this thing melts down, it pops the fuse, and then you can't do any more damage to the card even if you tried. At least as long as you don't break up the soldering iron. So I was like, oh, this is gonna be a free repair. This is gonna be a 5-minute repair. I'm gonna get a working 980 Ti, which is why there's also no recording of the actual repair process, because I was just like, well, that's a 5-minute repair. Like, I just got the package with the cards, and I immediately pulled the 980 Ti and was just like, I'm gonna find the dead dual end FET, remove it, replace it, and then I have a working 980 Ti. It's only after I already had replaced the dead dual end fed that I realized that this repair was gonna be a whole lot more complex than I thought. So yeah. But anyway, once I took the card apart and began checking, I noticed that the fuse had been tampered with. Because someone bridged the fuse with a piece of wire. And that piece of wire was burned through. So evidently someone turned the card on and didn't remove the short circuit before turning it on. The short circuit started drawing enough current to melt the piece of wire that was jumping the fuse. And that's the point where I should have realized that this card is not coming back. Because that's exactly why this card is now non-working, even though the electrical issues with the card have all been fixed. Like, it doesn't, I don't have a fitting fuse, so I just put a blob of solder where the fuse would be. But like, the memory VRM now works, and actually is now twice as strong as it's usually on this card. So yeah, like, everything works. Like, on an electrical level, this PCB is perfectly working. Problem is, well, when that person who tried to repair this card jumped the fuse and like burned through that piece of wire they put over the fuse, 12 volts must have gotten into the memory chips and memory controller. Because the memory controller is hyper dead. Like, dead. Not coming back dead. I ran a MATS test on this thing. Like, as soon as I got the memory VRM working, I immediately, like, even in BIOS, you don't even have to go into Windows. Already in the BIOS, this thing, like, artifacts. Like, that tells you how dead the card is. Anyway, I managed to run MATS, and yeah, so like, on this card you have 6 memory channels, like every 2 memory chips are memory channel. So, channel A, dead. Channel B, dead. Channel C, dead. Channel D, dead. Channel E, working. Channel F, dead. So 5 out of the 6 memory channels are dead. So yeah, it's the core. Like, it is technically possible that out of the 12 memory chips, 10 died, and then the 2 that didn't die just happened to be in one memory channel, but it's far more likely that the thing that's actually dead is the memory controller in the GPU, because like every channel of the memory controller is kind of like its own thing in the core. So you tend to see like certain channels dying, and even if you replace the memory chips, the channel is still dead, because it's actually the memory controller in the GPU core that is the problem. So yeah, like these 2 chips work fine, and all the others spit out like thousands of errors. And that like pretty much tells me it's the memory controller. Like, the chips might also be damaged. Like, they also got way more voltage than they should have. But because of the way how it fails, I'm fairly certain it's the memory controller on this thing that's dead. Which means the only way to ever get this thing working is to replace the core and possibly also some of the memory chips. Which is just not financially feasible because it's a 980 Ti. Like, I'm not only lacking the equipment, just like getting a 980 Ti core that's like known good is probably more expensive and harder than just getting another full like 980 Ti that no one's messed with before you, and then just try and fix that. So yeah, like, if this was like a 30 series or a 40 series, or maybe even like a 20 series, like one of the more expensive ones, swapping the core is an option. Like, I still don't have the equipment for it, but like a repair shop might do that. But for anything that's older than that, well, maybe you might be able to talk a repair shop into swapping a 1080 Ti core. But like, 980 Ti's these days are not relevant enough anymore, where a core swap, or actually just like a memory swap, like you can swap maybe 1 or 2 memory modules, but if you need to swap more than half of them, that's also like reaching the point where like yeah, it's gonna, like, because you need to get new memory chips and you're gonna need to spend a lot of time swapping them, you might as well just buy another 980 Ti. So yeah, so the card is not coming back. Like this thing is dead. And yeah, the moment I saw the jumped fuse with the burnt piece of wire on it, I should have known. And this wasn't the only thing that told me like the card is probably not coming back. Actually, after fixing the short circuit right here, like finding the dual end FET that was dead and replacing it and adding the other two so the VRM wouldn't blow up again, I also did a resistance check and I noticed that the output of the memory VRM was basically shorted to ground, which it normally shouldn't be. Like normally you wanna see like 20 to 60 ohms or so. This has 0.3 ohms, and it still has 0.3 ohms. And like the thing is, a short circuit on the output of a memory rail is really scary, because I've never seen a single card with a short circuit on the memory output rail that like came back. Like every single card that I've seen with a short circuit on memory was unrepairable. Now technically you can have a card that has a short circuit like that and repair it, because things like capacitors can sometimes go short circuit. Like if the voltage was high enough, these tantalum capacitors here might have just died and short circuited. And sometimes multi-layer ceramics, if they get physically damaged, they also short circuit. Maybe there was also just like a little bit of debris under the BGA of the memory chips that was bridging them. Like I did clean the card to make sure that's no longer the case. So yeah, like there are a couple ways how you can have a short circuit on the memory output and the card's actually fine. But yeah, that's not the case for this card. So the reason why I'm measuring the very low resistance is probably again because the memory controller is dead. And yeah, I'm just measuring that. It could also be that one of the memory chips is dead, and also internally. It could just be both that's internally short-circuited, because evidently, when this piece of wire burned, it took long enough for this to reach a very, very high output voltage, and that just destroyed the memory controller and possibly some of the memory chips as well. So, yeah. So this is the second 980 Ti G1 Gaming that I get that I can't repair because someone else already destroyed the card before I ever got it in my hands. And this is just... yeah, it's... like, I put these videos out there so that people see them, and when they try to repair their cards, do the correct thing. And don't just like jump fuses and expect that's the entire repair. Fuses don't just pop like that. Fuses pop because there's a short circuit somewhere. You can't just jump a fuse and then expect the card to work. What's gonna happen if you just jump a fuse is the card will break even further. Like this one. Like if that person hadn't jumped the fuse, I would have a working 980 Ti right now. I would have fixed the short circuit and then the card would just work. But because that person jumped the fuse, that shot 12 volts into the core, and now the core is dead. Like, yeah. So like, yeah, I just hate it when I see people try to repair things but only make things worse. And yeah, like I can't entirely say if it's disappointment or I'm just angry about it. It's just like, if you're gonna try to repair something, inform yourself, like educate yourself on how to repair things. Like, I know the video guides I make are long, but it's a complicated topic. If it's too hard for you to understand, then just don't try to repair it, please. Give it to someone who knows what they are doing. Because this 980 Ti is dead now. This is not coming back. This is trash. I can maybe scavenge this for parts, maybe turn the V-Core VRM into an E-Power, but this is not gonna be a working 980 Ti. This is trash now. And all of that because someone couldn't be asked to like read a guide or watch a video. They were just like, oh, fuse blown, just jump fuse, and then yeah, and then the card was dead because I don't know. Does it not occur to people that fuses, you know, have a purpose? Like, they don't just put fuses on there because they like making their PCB more complex and expensive. They put fuses on there so that when a short circuit happens, that short circuit doesn't kill anything downstream or causes a giant, like, crater or like, worst case, a fire. So when a fuse blows, don't jump it. Like, fix the short circuit first. And then you can jump a fuse or replace it with a blob of solder like I did. Like, ideally you wanna put a new fuse there, but I just don't have any fuses, and, you know, for testing purposes this is fine. If you want to sell this to someone, then absolutely put a fuse there. Like, yeah. Because I see this fuse jumping thing so often. Like, this is not the first time I've seen this. This is like, how many times? At least the third time that I've seen someone who has like a short circuit on their card just jumping the fuse and expecting that's the repair. That's not the repair. You're making a symptom worse. You're not fixing the problem. You're just making a symptom worse and potentially turning like a fixable problem into a non-fixable problem. So yeah, it's just this could have been a working card. This could have been a working 980 Ti, but it's not. And I can't do anything about that. It's just, this thing's broken. So yeah, I guess that's it for the video. I hope the next one's gonna be better. I have 4 more cards to go through. One of them's a 1080 and the other 3 are 780 Ti classifieds. So yeah, gonna be interesting. Hopefully it's gonna be a better story than this. So yeah, stay tuned. So yeah, thank you for watching, and until next time, goodbye.